to find the derivative of 1 over x squared using the definition of the derivative, which is limit as h goes to 0 of k of x plus h minus k of x all over h. So first thing we have to do is set this up. So if the limit as h approaches 0, k of x plus h, that's our function k, with x plus h in as an input. So what will that look like? 1 over x plus h, the quantity squared, minus k of x, which is 1 over x squared all over h. Now, a good rule of thumb when you have a fraction in a fraction is to find a way to simplify that fraction. One way of doing that is getting a common denominator. So the common denominator is going to be x squared times x plus h, the quantity squared. So we're going to give both of our fractions the same common denominator. So we have the limit as h approaches 0, and we want to write that until we've actually taken the limit. This first part is going to become x squared over x squared times x plus h, the quantity squared, minus this second part is going to be x plus h, the quantity squared on top, over x squared times x plus h, the quantity squared. Now remember, this whole thing is over h. So that's the numerator. There's our little denominator there. So we got the limit as h approaches 0. We're going to write this in a single numerator, so x squared minus x plus h, the quantity squared, over just a single denominator, x squared times x plus h, the quantity squared, all over h. Sometimes here students have a desire to try and do some canceling. There's really not any canceling we can do at this point. In fact, we set it up like this, so we want this stuff in here. Now I'm going to write this as h over 1 because I'm going to flip it and multiply just so I don't have a fraction in a fraction. The other thing I'm going to do between steps is multiply this out. Now x plus h, the quantity squared, is not x squared plus h squared. It needs to be FOILed out. So we have x squared minus, and I'm going to do it in parentheses. It's going to be x squared plus 2xh plus h squared all over x squared times x plus h, the quantity squared. Now instead of writing it all over h, I'm going to multiply by 1 over h here at the end. It's the same thing, just a little bit cleaner way of looking at it, and it'll be useful going forward. And what I'm going to do is I'm going to distribute this negative sign to all those terms, which is essentially going to turn them all negative. So I have the limit as h goes to 0 of x squared minus x squared minus 2xh minus h squared all over x squared times x plus h, the quantity squared. And for right now I'm just going to write it as times 1 over h. If you wanted to put the h here, that would be fine as well. Equals. Now I still haven't taken my limit as h approaches 0. Notice those x squareds cancel out. That's very important for us because now our terms have an h left in them. So I'm going to factor an h out of that numerator. So I got minus 2x minus h all over x squared times x plus h, the quantity squared, times 1 over h. Now take a look. If you distribute that h back through, I should get back to exactly what I have here. This is good for us because these h's cancel, which now allows me to plug 0 in for h. This term here is going to become 0. And so now I've taken the limit. I'm going to get negative 2x. This h here is also going to become 0. And I'm going to end up with x squared times x squared. Now there's some simplifying we can do here. I can cancel out one of the x's in the denominator with this one on top. So I'm going to get negative 2 over x squared times x. And typically what we'd do is write that as negative 2 over x cubed. And there is our k prime of x using the definition of the derivative.